Okay, let's jump right into this explainer. Today, we're exploring a genuinely mind-bending question. When something looks completely different from different viewpoints, does reality itself actually change, or is it just the way we see it? We're going to unpack a deeply fascinating paper by Ryan McLean called Light from Light. It uses physics, everything from simple magnifying glasses to quantum fields and even black holes, to figure out exactly how one single reality can give us so many radically different pictures. Now, to anchor our journey today, the author brings in a surprisingly profound quote from, of all people, Bob Ross. It really sets this contemplative tone about human observation in nature. It reminds us that encountering the world isn't about perfectly possessing it, it's really about how we perceive it from our own specific vantage point. And that brings us right to the core thesis of this paper. I mean, if you and I look at the exact same thing and see something totally different, is reality just an illusion? Do we literally live in different universes? McLean's framework forces us to stop and ask a much more disciplined question. When the picture changes, what actually changed and what stayed exactly the same? You know, Bob Ross understood something truly fundamental here. To know what a tree looks like, you actually have to spend time with nature. Encountering reality is all about reception and perspective. You are receiving a limited projection of something so much larger. Which brings us to an incredibly helpful classic analogy that the paper leans on. Imagine you and a friend are standing on opposite sides of a giant elephant. You see a trunk, your friend sees a tail. You don't start arguing and declare that the universe has magically created two different elephants, right? If you only see the tail, you don't declare the trunk an illusion. You simply realize that one reality can provide multiple, highly limited views to different receivers. Essentially, reality doesn't owe everybody the exact same selfie. Section 1. The everyday physics. How lenses change the message. So, to really wrap our heads around this, we have to look at how information flows, what physicists call an invariant structure. An invariant structure is simply the underlying reality that stays exactly the same even when its outward appearance changes. For you to see anything, three things have to happen. First, you have a source, right? The origin of the information. Second, you have the channel, which is the path the light travels, and that path might bend, stretch, or scatter the light. And finally, you have the receiver, your eye or camera, capturing whatever actually survived the journey. You aren't swallowing the object into your eyeball, you're just receiving a message from it. Think about it like this. If you stand in front of a funhouse mirror and suddenly look, 6 feet wide, the mirror just changed the channel. It didn't secretly perform emergency surgery on your actual body. A magnifying glass, a prism making a rainbow, or a glass of water bending a straw, they're all just altering the path the information takes before it reaches you. Okay, so that perfectly explains optical illusions and funhouse mirrors. But what happens when we look closer? To really put this one reality, many receivers idea to the test, we need to zoom all the way down to the fundamental building blocks of the universe. Section 2. The quantum scale. Waves, fields, and excitations. Let's dive in, because this is where things get wonderfully weird. This framework corrects a massive, everyday misconception. Most of us imagine light as millions of tiny glowing marbles just zooming through an empty void. But quantum field theory tells us the universe isn't filled with independent, unrelated little pellets. Instead, there are underlying unified electromagnetic fields, and what we casually call a photon is really just a localized excitation, a little spike in energy within that single overarching field. Think of it like the ocean. There can be a massive wave, a tiny ripple, and 100 little splashes because someone skipped a rock. But we don't need to invent a brand new, independent ocean for every single splash. We can have billions of distinguishable excitations, what we perceive as light and color and radiation, all belonging to one underlying physical structure. It's one field with many excitations. Section 3. The speed limit of reality. Relativity and causal limits. Let's zoom back out to the sheer fabric of space and time. Einstein's special relativity tells us that the speed of light is the absolute, unbreakable speed limit for information in the universe. And this creates what physicists call a light cone. Because information literally takes time to travel, you can only see or interact with events that have had enough time to send a signal to your current location. If a star explodes right now, 10 light years away, it's entirely outside your light cone. It's totally real, but it is physically impossible for you to receive that reality just yet. And because of the speed limit, we run into, honestly, one of the wildest facts of physics. There is no such thing as universal time. There's no master cosmic clock ticking away the exact same now for everyone. Instead, there is proper time, the time measured along your specific, unique path through space. Two clocks taking different paths through space-time will literally record different amounts of time passing, yet they both belong to one reality. They just receive that reality through completely different historical paths.
Because of this absolute speed limit, absolutely everything you see is already in the past. When you look at the moon, you are seeing it as it was about a second ago. When you look at the sun, you are receiving information that's already 8 minutes old. Your personal now is really just the local spot where all these historical messages finally happen to arrive.
Now we know a glass lens bends light, but what if space-time itself is the funhouse mirror? What if the very fabric the light is traveling through gets warped? Section 4. The Cosmic Funhouse Lens. General Relativity and Gravitational Lensing. Let's see how this plays out on a massive scale. Imagine you hide a flashlight behind a giant bowling ball. Normally, you shouldn't be able to see it at all. But if the bowling ball was somehow heavy enough to bend the actual space around it, the light from the flashlight could sneak around the sides, reaching your eyes from multiple directions. This is gravitational lensing. Massive objects like entire galaxies actually curve space-time. Light from a background object travels along these bent paths, and when it finally reaches us, we might see a whole ring of light or multiple mirrored images of a single source. So when astronomers look up and see 4 identical quasars in a circle, they don't assume the universe just decided to build 4 identical quasars in a suspicious little ring. No way. They realize that one reality is being projected to us through multiple bent channels. And because those paths are different lengths, the light arrives at different times. You could literally watch a star flicker in one image and then watch the exact same flicker happen in a different image years later. Section 5. The Grand Synthesis. One reality, many receivers. Let's bring this all together. This perfectly ties these mind-bending physics back to the author's philosophical framework. You see, our naive intuition says that if there is one reality, it should look exactly the same to everyone, all the time. But the actual physics of reality shows us that one reality produces multiple projections. Whether it's a funhouse mirror, a quantum field, or a whole galaxy bending a light cone, the underlying invariant structure remains perfectly consistent, even as the appearances change endlessly. Ultimately, the absolute main takeaway from the paper is this core idea. Real unity does not require us to erase real differences. One reality can be encountered by many receivers. Just because you and I receive totally different signals, just because we're standing on different sides of the elephant, doesn't mean we inhabit different universes. We don't have to erase our different perspectives to share the exact same truth. It turns out, the universe is incredibly rich. It's mathematically and physically robust enough to supply countless, unique, valid perspectives, all stemming from a single, beautifully unified source. The channel changes, the receiver changes, but the source remains. Which leaves us with one final, kind of beautiful question. As a receiver, what parts of reality are quietly hiding just outside your light cone, waiting for you to change your perspective so you can finally receive them? Thanks for joining me on this explainer. I hope it changed the way you look at the light around you.